Hi guys, welcome back to my study live stream. Now it's 21 o'clock 53 and we begin the study live stream. And just now it's 7 seconds and just flip by, and then now we formally start. Today is not a special day, but it's a meaningful meaningful datum that carries on a lot of Bedeutung. And and today's date is 5th December 2025, and we begin now direct study, because I feel like not very much attractive if I speak too much, and so that we're gonna make that seconds count, right? And we recently moved to the new place, and since 20 days already, and I got a real how to say that, like rewarmed up, like recovered a little bit, and I feel like fit now. And so what we're gonna do is that the Waschbecken got some problem, like the fringe that they not very well, and because of also the Breitenbachplatz that vermieterin, and so I cannot deal with that, and we're gonna find a solution recently, and to go to the Bauhaus and Baumarket and to find some, I would say some some small like small pieces that you can to the wood, inner wood, and then to by the 3 seconds caliber, so that they both sides can somehow clip together, and to repair it as I could. And another 2 points, it's like how to say that, like we're gonna also figure out in how to wipe first the outside Fläche, and then to say what could we do, what could be done, so to say, and that the other problem is that same of Boden. The Wohnung is not new, the apartment is not new, and they have previous renting. They have the same problem, like French problem. It is not because of the activity, which it could also be, but the most reason is that the French got a problem because they all don't have the doctor degree, or they pursue and they want that, and so that the French got the problem of Boden, of wood Boden, and of the Waschbecken, and so the same problem. Yeah. So let's just figure out how to do it. But I'm gonna make that into the IKEA. But I'm not sure whether IKEA can deal with that, because we weak boxes that only be available in the IKEA. Otherwise, Bauhaus 2 marks, like Auto and etc. gonna repair. But it is like a big problem, so to say. And this problem happened majorly in the academic family, and so they sometimes like do very dangerous thinking behavior, and so that this problem happening. Like some marginal behavior and etc. So this problem happening, and we today need to use the Stromhose. We use the Staubsauger, and to clean the insect which generated from the unemptied overnight tea. And so a lot of problems, and need to organize and bring the things from the blue ground into here. a lot of heavy work, but we're gonna to pick up what is important, and then call the Umzug-Firma and directly move like within 2 to 3 days. I say, and then to the new place, and hopefully that will be done in a very efficient way. And in phase, and we left that over, and I feel like be conjuncted. And the reason is that they, without asking, directly break into the apartment, even that we are out of the contract relation. But still, that is private things and private substances. So I don't really hope that they don't because if, for example, like if you want to rent afterwards or service fee, like because I haven't lived there for 4 months, 5 months already, half a year, and so I always pay until October, and then they ask me like Servicegebühren, I paid, and so I think that we are going to go through the final colleagues, not this run company. We're gonna go through the final give key back and give things up, this kind of process. And so I hope that like Fitz can also deal in 3 days, and so we kindly are free from this two rent company. If it is possible, then it's before Christmas. And as Professor Kanu was suggesting, better suggested in mind, so to say, and better you sacrifice like 10 days and don't go to university, and unless you have a presentation or etc., and you just disconnect them, and so to say. But before the things move in, we should to buy some flasks. So on the trunk here, it is to protect Boden and protect Boden, and in order to make further destructions, so to say, because I think that it is kind of, if it is towards the pattern, not necessary, and we can say that is as previous rendering that as well has cost of the burden, and we can say that is the and but we're gonna not do that because we are the good people, and we're gonna not do that. We're gonna commit it to what we would wrong, and simultaneously to think how to repair it, and but take that serious. Do not provide that to others if it is really made by you, for example, and yeah. And then yeah, finally we got the funding today from my family members, and and I've been suggested just laying down like 10 days, and 7 for the second one, and the 3 for fifth, and to completely focus on, and like the Professor Shiva, and just like start 2 weeks after the lecture, and not think that much, in a sense. That in a sense that yeah, okay, we talk too much. In a sense, we're gonna repair it, but you shouldn't worry about that, because they're saying previous filmmetering that they also have the similar problem, and but we have also not blamed, and that is the bit cost, and the fees, if it is the asking cost, and we can pay the Servicegebühren, and the Blue Ground has not pricing, and so we don't know what is the daily price. And so, for example, like we can pay them like 20 euro each day, because I haven't lived there anymore, and I transferred last week 10 days ago, 10 days ago, 9 days ago, and about about the about 700 some euro, and after the transaction, and I bought several stuff, and but it is not exceed the too, yeah, exceeds too much money, and but I don't know why recently I haven't had enough time enough money in my account, and so that I wondered, I want to check that, but I don't think that they're gonna give me the right correct answer, and so that it also matters, but we're gonna figure it out. But it is because that is not difficult, and the other problem is that and yeah, there is no other problem anymore. And let's jump into the study content. And yeah, just let's do it. Yeah, today I feel like very much appreciated to the classmates because that they allowing me to add my name and together with them. And one is Jupiter and one is Hyperlink, and both are new color. And so that I feel like that's great. Yeah, I haven't opened our code, and since yeah, okay, this watch is actually new, very new, but it is already okay, fine, it is already 让虫给叮了，然后上面有很多的这种虫的这种就是叮过的这种就是痕迹，然后让人觉得非常恐怖。然后因为才搬过来没有多长时间嘛，然后我的 study Livestream 里面，然后我们 gonna speak we're gonna speak several languages. One is English, my second preferred language. When I feel like very incompetent, I'm gonna speak Chinese, and the third language is German, my academic writing language. And recently we got a task to write for next week, the week 9, and write something like for the previous Femita and etc. I don't know, like you just think that is the Cockfield and etc. Yesterday I feel like one thing I don't really align with is the yeah, okay, we'll just ignore that because that is not embarrassing, but it feels like feels like you those kind of people that who really have somehow discriminated aspect towards the people who are not smart, for example, and they I think everyone is equal, and there shouldn't be ignored, so to say. If you ignore, make ignorance about that and feel really bad, or you can say that it is the core of this soul and is the physical body and about one's soul existence. So, but from my point of view, I think that you should respect and you should treat them equal. And the reason is that towards life there is no much difference, and whether you can perceive like I know I also be discriminated today, at least by the Jack Wright, and so it feels 不爽 it feels really 不爽非常不爽 but you have it to deal with that and so yeah let's go And I found one thing is that we can replay the Professor Notes video and I recorded story. I think that is okay, but I don't think that's really not allowed. And I'm willing to share with classmates if they want. For example, and of my sometimes if I have time, I'm gonna upload it in my YouTube channel. And somehow, if for example, like university Bereich faculty, they were to not charge me, like put me into some university president bureau and to explain why you did that, and I gonna say I'm a foreign students and my language skill was not well, and so sometimes I think with myself and when I record also because the university examination was one process you're gonna go through, and sometimes you, for example, compared to previous experience, for example, in the evaluation time period, and they got several weeks, for example, and for example, by what talent wrong, and you're gonna find the evidence and how they said and what they said, and you should take responsibility to what you are saying on the class. And the reason is that if you have the injustice Bewertung towards one clausur, for example, one examination, that is not everything mode, that is not everything Imanu professor, and so from my side, like my point of view, and I have this, and now currently I raise my conscious and for the university and for the normal thinking pattern, and so I find this useful. You can find some hint, and for example, like you write something and they said that it's wrong, but they said in the class on the class that is right, and so that you're gonna find the proof, like the evidence, and they said wrong, and they should give you the points, and instead of not two, and so I think it's much more important. On the class, it is kind of like a Anhörung zum Beispiel, like a 听证会, and the one who are not allowing to have the thinking ability to express themselves in the mind level, they're gonna they have the only rights to her. It seems like they are all the sinners, and to listen what they are did wrong, and so you have to prove and to compare and to improve your study process, and for example, like not feel like weakened as a weak people group towards the authorized university side and the professor and its their teaching team, for example. And so from my point of view, this is useful, and if I have sufficient specialized like time, I could potentially do that. If I think that they're gonna judge me wrong, for example, I take that as evidence and to prove myself I am right. And so also because several questions are constructed with the subjective evaluation, and sometimes you don't have a certain answer, and depending on environment, depending on your competitive students, and depending on a lot of factors. But I don't want to they really judge me wrong, because one problem is that I don't really have that much time to waste anymore, and I need to get a degree done. And so yeah. So another problem is that last semester I don't know, but Professor Fritz already compensated. So I feel like the Latin American Institute professors were all nice, and so I really don't want to blame them any. so that from my point of view, if you can benefit from, you absolutely won't tell anything. and and so in this sense, even it could be that the last semester of finance case own system in the program Bruno has bad judged, because they could, for example, they could give like 5 to 6 subjective evaluation in the latter part, and just like give a satisfied grade, because that will not influence the Gesamtnoten zum Beispiel, and let me to like feel freely to feel relaxed to graduate, and instead of to make that parallel two measures together, and it is kind of also haven't got the time really to back my hometown, and I need to visit my family, and I need to take care of them, and I cannot always spend so much money on their orders, but their orders won't give you the feedback, or won't give you some positive rewards. For example, it's purely like consuming self, and that is one thing. And my point of view, and I don't want to make any involved in any conflict, and etc. So let's just do it today, and we got to review today morning, and we're gonna directly to professor's video, and but not toward other students, and only the roof of the classroom and the face part of the classmate won't be recorded, so to say. And yeah, I could also potentially not say that, but I think that is reasonable. And you can search for the Mitteilung at Free University, and they have exactly. I don't know whether it's exactly, but it's somehow irgendwo geregelt, dass man das machen können. Yeah, okay, let's just do it.
theory. And look what the intuition is. The very strong hypothesis or assumption or proposition there from centralism theory is that if you have, look here, this is one word, if you have a random variable that is IID, so we have a set of IIDs, all are, however, not necessary. But they're identical. We all have all the same solution. So you draw, for example, randomly from some sense. Right? You don't know the solution, but it's all the same. They're all identical. And they're independent here in this very strong version. So they're independently identical. So they can tell you, and here this is a very basic form of centralism. We take this time for it. Okay? Welcome. Okay, so we have a commentary. So we are still in the same, understanding. So, and now look what happened. We add up all these random variables. Yeah, we have 100 or 1,000 or however, how many of them we have realizations of these identities with random variables. And if we just take the average, or just take the sum of it, right? The same, right? One can show that this variable here, converges to the normal distribution. So this is again a random variable, obviously, right? But the exciting result is, even though the x's here are not normally distributed, right? They might be heavily skewed or whatever. If n goes to infinity, if we have only enough observations, then the distribution of this statistic here is very close to normal distribution. It converges the distribution against normal distribution. So this is already exciting, a very strong assumption, but it's getting more exciting, right? So you can't even, the point is here, you see that it's important to have here identities, independent things. Right? So how important is that assumption that they're independent? Assume for a moment that you skip that, and that you just allow, for example, the extreme case, that they're super coordinated. Right? Draw the 1,000 n x's, right? The same distribution, but actually they're super coordinated. So let's go to the extremes, right? You draw always the same. So these xi here, in our extreme example, are actually identical. Alright? So not independently, no, they're just identical. Just draw down 100 times the same number. Okay? Is it possible that the central limit theory still works in that extreme case? Here is a pure case. Independent. Well, very strong assumption about the axis. They're independent. Now I take the other extreme, somehow strange extreme, that my n axes here are not independent, but they're identical. I just repeat. I draw once and then I repeat 100 times. So can it still be possible that this is always here? What do we say? Yeah? No, because we count is 0, every number is. No, the mean can still. Come on, if I have random variables being 0, then the expected value of if I draw once is 0. And if I multiply it with n, it's still 0. That's not the point. So, most simplified is meaning that if we take out the n goes to infinity, right? So we have asymptotically modifiers. So when we go from strong exponent have a lot of inputs. And second, there will be something about normal distribution. So we still A1 and T, that was in our slide, that was as long as it's 80, and that was the math. Right? All right. So now we talk about asymptotic theory. So what happens with the distribution of the test system if n goes to 2? And here is the root of everything, the basis theory that helps us when we talk about asymptotics. And then also explains why the normal distribution is so central and so important for statistics. This is one word, one of the 20 words of central theory. In German, zentrale Wechselmessers. Central human theory. And look what the intuition is. The very strong hypothesis or assumption or proposition there from central human theory is that if you have, look here, one word, if you have a random variable that is IID, but you have a set of IID random, all are, however, not necessary. But they're identical. They have all the same distribution. So you draw, for example, an observation from randomly from some test. Right? So you don't know the distribution, but it's all the same. They're all identical. And they're independent. Here's a very strong word. So they're independently identically distributed. They have some effect value, and here is the basic form of central distribution. Okay. Welcome. Okay, so we have constant variance. So we are still in the same under standard snapshot. Right? So and now look what happened. We add up all these random variables. Yeah, we have 100 or 1,000 or whatever, how many of them we have realizations of these identically distributed random variables. And if we just take the average, or if we just take the sum of it, right? So the same, right? One can show that this variable here, converges to the normal distribution. So this is again a random variable, obviously, right? But the exciting result is, even though the axes here are not normally distributed, right? They might be heavily skewed or whatever. If n goes to infinity, if we have only enough observations, then the distribution of this statistic here is very close to normal. It converges against normal. So this is already exciting, very strong assumption, but it's getting more exciting, right? So you can't even, the point is here, you see that it's important to have your identities, independent things, right? So how important is that assumption that they're independent? Right? Assume for a moment that you skip that, and that you just allow, for example, the extreme case, that they're super coordinated. Right? Draw the 1,000 n x's, right? The same distributions, but actually they're super coordinated. So let's go to the extremes, right? You draw always the same. So these xi here, in our extreme example, are actually identical. All right? So not independently. So no, they're just identical. Just draw down 100 times the same number. Okay? Is it possible that the central human theory still works? And that is the case. Here is a pure case. Independent of very strong assumptions about the axis. They're independent. Now I take the other extreme, somehow strange extreme, that my n axis here are not independent, but they are identical. I just repeat. I draw once and then I repeat 100 times. So can it still be possible that this is always here. What do we say? Yeah. No, because we count is 0. Let me know first. No, we can still. Come on, if I have random variables being 0, then you know the expected value of if I go once to 0. And if I multiply it with n, it's still 0. That's not the point. So, I have 100 times exactly the same variable. So, the idea of this here is I have super skewed distribution of x, right? Maybe it's, or I have a uniform distribution. So I have a distribution of x which is definitely not normal, right? Like this bam, not like Laos. Strange distribution. Okay. And this here tells me even if x is super strange distributed, if I just sum it up, you know, n goes to infinity, bam, normal. Okay, that's central limit theory. And what I'm now asking is, well, do we understand this? So, do we understand why independence plays a role here? And whenever we present formulas here, we understand formulas. If we do something strange with the formula, goes to infinity, goes to 0, all identical. And what happens? Do we understand or not? If not, then more times. Okay, so look, if I have 100, say, super skewed distributed x, and I have this one thing, and I just take always the same thing. What is the resulting distribution? So it's still skewed, right? Because I do not add up new information that where something can cancel out, or I have only one thing and I just add it up n times. So what's skewed for everything? All right, there is no conversion. Okay. So I need that these n realizations of the random are not perfectly correlated. And in fact, stronger versions of central theory have weaker assumptions about correlated structure. So one can show that central theory still holds if the correlation between the axes is not too strong. Right? In my super stupid examples, it was perfectly correlated. If they're perfectly correlated, no central theory works. Okay? So if you add the new x, there must be new information and something has, you know, there must be the possibility that something cancels out. Very high, very low, and up. Right? This is the idea of central theory. Okay, so this is very good news, right? Because independence is a strong assumption, right? But it works actually much weaker. So this central theory shows you why the assumption of normal distribution of a random variable is not very critical. Because if you have a lot of observations and in your statistics somehow make some averages of these random variables, they are not normal distributed, then you can say that's probably. Okay, well that helps us a lot because this means that this one here, which was derived under the assumption for finite n, right? For finite n under the assumption that the residuals are normal. This implies immediately that this test statistic, which is somehow, you know, if you look at the formula of theta n, which is a picture of all the u's and the x's, you know, you sum up y by n and form 1. So you can easily apply the central limit theory to the theta 2 hat. And this shows you why the absence of normally distributed errors is not a big issue if you have a lot of observations. asymptotically, we have a lot of observation, that hopefully we have this, right, in economics. Having normally distributed errors is a nice thing to have. If you have a lot of observation, it's not so good. Okay, because of the central theory that tells you if the views are not so correlated, then you sum them up like you did in the bigger two hat. You got the formula, how bigger two hat depends on views, right? Then you see that this gives us normality, asymptotic normality of bigger two. Okay. So this is one reason why still, in all papers, in all math theses, you would apply t-tests and f-tests and everything, although nobody really checks whether they are normal or not. Because they have a lot of observation, who cares? Okay. Of course, this is n goes to infinity, and you will never have infinite many observations. Therefore, the closer the residuals are to normal, the better. Right? Because you can easily simulate that if you want with R, right? Just look at the distribution of the things. Of course, this this conversion here goes quicker, the more similar the assets are already, the more close the assets are already at the normal, right? So if X is already normal, then we have already defined sample that is normal, right? And that conversion is really quick because you're already there, right? If X is close to normal, then it goes very quickly, right? But if you have, for example, a high equal distribution, then maybe you table some large n in order to But let's talk a little bit about the uh, why we need sorry, why we need certain scales of n. So suppose you just want to talk about the difference here between beta 2 and beta. So not the statistic, I something, but just the difference. Right? What do you expect for the distribution of that random variable if n goes to infinity? What about the expected value of that? That's more or less. If alive they can down that or doesn't work. Yeah. Or
OK，我们现在要充一会儿电，所以先等一下。
Nach der Länderspielpause eröffnen 2 Teams aus der oberen Tabellenhälfte den Bundesligaspieltag. Der SC Freiburg auf Rang 5 ist zu Gast beim Tabellenzweiten aus Wolfsburg. Den ersten zaghaften Schuss gibt Svenja Völny in der 3. Minute ab. Sie beginnt im Sturmzentrum anstelle der erkälteten Luca Börkholz. Unser Respekt vor den Top-Teams der Liga ist noch ein bisschen zu groß, sagt SC-Trainer Edmond Kaplani. Im Vergleich zur Pokalniederlage hier vor 3 Wochen will Freiburg mutiger auftreten. Und das gelingt ziemlich gut in den Anfangsminuten. Selina Fobian auf Lela Egli. Die Führung für den SC in der 11. Spielminute. Das dürfte das Selbstbewusstsein sein, das sich Kaplani gewünscht hat. Egli zögert nicht lange und sucht direkt den Abschluss. Es ist ein perfekter Schlenzer der Schweizerin, bereits ihr 3. Saisontor. Keine Abwehrchance für Stina Johannes. Die Gastgeberinnen sind bemüht um eine schnelle Antwort. Flanken sind da ein gern genutztes Mittel. Logisch, wenn man mit Alexandra Popp eine der besten Kopfballspielerinnen der Liga hat. Benkert pflückt den Versuch in der 17. Minute. Beim VfL ist Lynette Bärenstein nach ihrer Sehnenverletzung noch keine Kaderoption. Popp daher Zielspielerin Nummer 1. Ihr nächster Kopfball 2 Minuten später. Für Cora Zikai ist es bereits das 2. Wiedersehen mit ihrem Ausbildungsverein in dieser Saison. Im Pokal traf die gebürtige Freiburgerin gegen den SC. Ihr erster Abschluss in dieser Partie in der 29. Minute ohne größere Gefahr. Aber der VfL nähert sich weiter dem Freiburger Tor an. Ecke Pujols und dann bekommt Latwein nicht genug Druck hinter ihren Kopfball. Die Gastgeberinnen versuchen es wenige Minuten vor der Pause mit hohem Angriffspressing und werden mit dem Ballgewinn belohnt. Alexandra Popp sucht mit dem ersten Kontakt den Abschluss, aber auch der stellt die Gäste vor keine größeren Probleme. Dann ist Pause in Wolfsburg. Der SC beschränkt sich nach der frühen Führung aufs Verteidigen. Kann der VfL die Freiburger Defensive in Abschnitt 2 knacken? Dabei helfen soll Vivian Endemann. Sie ist nun für Ella Pedemos im Spiel. Die Wolfsburgerinnen kommen mit ordentlich Tatendrang aus der Kabine und erzielen in der 51. Minute den Ausgleich. Die Frage nach der Torschützin gar nicht so leicht zu beantworten. Die Flanke kommt von Scherland. Freiburgs Stegemann fälscht mit dem Kopf ab und Popp ist tatsächlich gar nicht mehr am Ball. Der Treffer gehört schlussendlich Justine Scherland. Stefan Lerch peitscht sein Team weiter nach vorne. Fällt direkt der nächste Treffer. Judith Pujols ist jedenfalls ganz nah dran in der 54. Minute. Pujols wird kurz nach ihrem Versuch ausgewechselt, genauso wie Zikai. Die beiden neuen Janu Lewels und Kessia Büssi initiieren diesen Wolfsburger Angriff, den Lena Latwein nicht veredeln kann. Die Hacke von Hut und dann Latwein glücklos. Mit einem Punktgewinn könnten sich die Freiburgerinnen sicherlich anfreunden, zumal offensiv kaum noch etwas kommt von den Gästen. Doppelpass zwischen Hut und Lewels. Lewels Schuss geblockt. Schellands probiert's. Benkert wackelt und Dijkstra sagt Dankeschön. Der VfL dreht die Partie. Laura Benkert in der gesamten Partie ohne einen Fehler begeht ihren ersten folgenschweren in der 68. Minute. Schellans Flatterball flutscht ihr durch die Finger. Die Führung für Wolfsburg verdient. Der SC hat sich zu sehr auf den frühen 1:0 ausgeruht. Berappeln sich die Gäste nochmal oder bringt der VfL die Führung ins Ziel? Viertelstunde noch zu spielen. Kessia Büssi sucht Vivian Endemann. Starker Einsatz von Freiburgs Kapitänin Lisa Karl, die mit einer Grätsche Schlimmeres verhindert. Zu Hause hat Wolfsburg seit 2009 nicht mehr gegen den SC verloren. Vieles deutet auf einen Serienausbau hin, auch wenn der Treffer Nummer 3 vorerst nicht nachlegen kann. Dieses Mal ist es Sigurd Dorfir, der mit ihrer Grätsche zur Spielverderber wird. Der SC setzt die Gastgeberinnen noch einmal in der eigenen Hälfte unter Druck. Den Wolfsburgerinnen macht das aber gar nichts. Die eingewechselte Janina Minge bedient Alexandra Popp. Das 3:1, die Entscheidung. Minge überspielt mit ihrem Ball das komplette Freiburger Team. Popp kreuzt gedankenschnell und schiebt routiniert ein. 7. Saisontor für Wolfsburgs Kapitänin, die damit für mindestens eine Nacht zur Spitze der Torjägerinnenliste aufrückt. Ein weiterer Gegentreffer bleibt den Freiburgerinnen erspart, weil Büssi in der Nachspielzeit im Abseits steht. Somit bleibt es beim 3:1 für Wolfsburg. Der VfL rückt bis auf 3 Punkte an den FC Bayern heran und macht Druck auf die Tabellenführerinnen, die am Sonntag im Topspiel zur Spitze der Torjägerinnenliste aufrückt. 1, die Entscheidung. Minge überspielt mit ihrem Ball das komplette Freiburger Team. Popp kreuzt gedankenschnell und schiebt routiniert ein. 7. Saisontor für Wolfsburgs Kapitänin, die damit für mindestens eine Nacht zur Spitze der Torjägerinnenliste aufrückt. Ein weiterer Gegentreffer bleibt den Freiburgerinnen erspart, weil Büssi in der Nachspielzeit im Abseits steht. Somit bleibt es beim 3:1 für Wolfsburg. Der VfL rückt bis auf 3 Punkte an den FC Bayern heran und macht Druck auf die Tabellenführerinnen, die am Sonntag im Topspiel gegen Frankfurt gefordert sind.
我们现在 continue。
Far away from we have to check or something like that. Right? So what do you do under the other hypothesis that if it is consistent. Minus 0, because that's what we as beta 2, we will get our actual beta. Consistency means that the probability that this difference here is large after the epsilon goes to 0. So if we look at the distribution of beta 2 minus beta 2 hat minus beta, this is something which has effect like 0, biases, but what about the variance of that? It goes like this. Because it's consistent. Remember, mean square consistency in our lecture means mean square error goes to 0. Means that it's unbiased estimator, the variance goes to 0. If the variance of something goes to 0, the distribution is not like this, it goes like that. So we have what we resulted if n goes to infinity, the distribution of that difference degenerates. Right? It looks like this is here, this light here. It looks like the red thing here. It's getting steeper and steeper and steeper and steeper. We have no well-defined distribution of the test statistic anymore. If we just use the difference of two estimates. Okay, here the simulation example is, so here we have standard normal distributions and varies from 1500 rows, and then we do this, for each end here we draw 10,000 of these 10,000 times, and then we plot here we plot 1 over square root n distribution of this. And on the right hand side, we scale with n, so we have this x bar, and then we multiply with n, and therefore we have just a sum here, right? We have to have a second look at these scalings. Here's scaling and there's no scaling, so we do not scale sum. Okay? Always scale x bar with factor n. And here you see, so here is just a sum of this xi's, right? Looking if we have n 15, n 15, it is possible that we have minus 20. It can range from minus 25, to 25 something. And the green one is, no, look here, the green one is 50. Yeah, look here. The green one is for a sum of 50 vectors, and you see already the probability that the sum of these here is less than 50 is by definition 0. Like, you have here normal distributions, it cannot be smaller than minus 50. And the probability that it's close to minus 50 is so small. Things for plus 50, of course. Expected value is 0, so it's centered around 0. You see it's somehow normal, right? But now you see if I increase the number of the ends, right? It is because of the standard theory, right? Convert or because of the consistency of the estimator, the distribution of that test statistic here, that one goes gets steeper and steeper and steeper. And if this would be 1,000, this would be 50. So you can't use entropy. You can't let n go to infinity. Right? So for consistency, and central theory, that all needs n goes to infinity. But if we let n go to infinity for beta f minus beta definition here, then we have no decent, non-degenerated distribution of the test. We want to have a nice, stable distribution of test statistics, like the T distribution, or the normal distribution, or the F distribution, whatever that we can use for our tests, right? Here, if n goes to infinity, if we do not have a proper scaling of the variable, then you see that it collapses. So here you see why you talk about square root n convergence in the context of statistics. because you see, if you look at this one here, if you rescale with, so you have x bar is this one here, right? And this is why it's called no scaling. Like you have just x bar. This collapses. If we multiply x bar with square root n, then we have this. Then we go from here to there, right? Multiply this here with square root n. That cancels out, remains 1 over square root n times this. And one can show that this curve, so if we inflate this difference, will converge because of the consistence of the estimator to 0. If we inflate this difference with square root n, then we have this thing. Right? So for all these three variables, we just multiply these things here with square root n, and it converges to the same. And this is more or less what we need here for this result. So this more or less illustrates this famous result here, that if we have here a linear regression model, and we have these errors, and we have the exhaustion effects, so that we know it's unbiased, right? Then one can show that, rescaling this difference with square root n here, which is just this one here. Here, you know that beta hat minus beta is just x prime 1, x prime u, right? We have this already. And now we do this, we multiply this left-hand side with square root n, because we know beta hat minus beta has no well-defined asymptotic distribution. It's just collapsing, right? Therefore, we have to inflate this with the number of observations. The square root of the number of observations that is the left-hand side, because here cancels out. So, sum up. Here the estimation error here is asymptotically normal because that whole zero n goes to infinity. The asymptotic covariance and the convergence rate is square root n, and this is why we call beta hat. Okay, so look, we have asymptotic normality without assuming that it moves. Where's the input here? This is the spirit of the central theory. We start with something not normal, then we have a lot of them, and we end up, and they are essentially uncorrelated. Here, we have a uncorrelated, right? So, and you see that this is a straightforward generalization of extension theory that this here is normally distributed, right? That this here is still normally distributed here, even if we have only immediate partial capacitors. Right? So the situation we love, we have only immediate partial capacitors, so lag partial variables are allowed, right? And we have non-normal errors. This is all covered asymptotically. It still needs normally distributed values. Okay, and this result explains why we still apply DNF tests all over the place in the applications, even though it's not so obvious whether the regressors are really strong exogenous, or whether these are really okay. So good news. Yeah, but as always, it's important to memorize that we have something one. So we have traded assumption of normality and strong exogeneity consider beta hat minus beta. Right? You want to make a test, and you want to make a test is significantly zero. So beta hat minus zero. Okay, zero. But if you have a consistent estimator, then you know beta 2 under the null goes to zero. Right? So the probability that you observe something which is not zero is just zero. So we have no stable test statistic like T or F or whatever statistic to do your tests. Because under the null, it's always, if n goes to infinity, it's always at zero. Right? So you will always reject, always. Because the probability that I always reject. Yeah, but this is the perfect certainty under the null, right? And the null hypothesis we assume to be correct, right? So just because, we will, and this is the one we always reject, right? So look, if you reject with certainty the null hypothesis, then there is no sense in doing the test anyway, right? Because you have a lot of observations and large, you assume that you have a consistent estimator, because by assumptions, then why testing anyway? Right? So if you want to have a statistical test with a stable test distributions, you have to explain this. Right? And of course, it's not, there is an intuition why you have to inflate the number of observations, why you do this simulation study to see, it then goes in the map. Right? But of course, it's not by intuition obvious that it's enough to multiply this parameter. Right? This is all of the Okay, so if we go from exact tests for minus n to asymptotic tests, then we can apply them even under the approach. So, and this case one we have to and chi-square, whatever depends on the normality assumption in the first case. Even though my non-contrasted that is strong, that you guys must only caution. You know that we still assume uncorrelated and almost nothing happens. Right? This is what we talk about next. Okay, so very closely related to testing hypothesis is the concept of confidence. Yeah, let us talk a few words about this concept, right? You already should know. So here is the confidence interval for a scalar beta hat. So think again, beta hat is on the square estimator, right? And under the standard assumptions, we know that it's T distributed, right? So that this here is that this variable here is T distributed with n minus k freedom. And the number of observations, k is the number of regressors. This is the distribution of looks like very already, obviously anywhere is not so small, right? So this looks exactly like the number, right? Yeah, T goes out there, normality is n goes, then it's much. Okay, so here is the 2.5 upper and lower one-time of this distribution. This is what is Q. Okay. So here you see Q 5% half, 5% half is 2.5%. So the probability that the value of T statistic is even smaller than that here is only 2.5%. And it's larger than that one is also 2.5%. So therefore, the whole Okay, so we know that this is now T distributed, so we know that probability that this random variable here is between these limits here is exactly 1 minus alpha, right? Because left is alpha divided by 2, right is alpha divided by 2, meaning that in the, that between this probability is just 1 minus alpha. Okay, and now there are two ways, to look at these things. One way is to, this is if you use the fact that this is let me try this. So now we talk about how to interpret that probability, how to use it, right? So because it's a symmetry, we have T alpha of is 1 is minus T 1 minus alpha half. Okay. And now that means that we can, so let us now rewrite this like this. Minus T1 alpha half is smaller than beta hat minus beta divided by the variance of that. Okay? And now I rearrange this series of inequalities, right? In two ways. The first way, I do it that I solve for beta hat, and then I solve for beta. So this is exactly the case when I multiply with the square root, and then I add beta. So this is beta plus beta minus T1 minus alpha half plus beta, and then times square root. So times square root. So first I multiply with the square root of the variance, and then I add beta. And then in the middle there's just beta hat. And here we have beta plus. Okay, this is one way to look at this. And the other way is I solve for beta. So that's a bit complicated now. So I just multiply with minus 1. So we have T1 minus alpha half is larger than beta minus beta hat minus the square root larger than minus T1 minus alpha half. Right, I multiply with minus 1 in order to solve now for beta. Okay? And because I multiply with minus 1, this here turns around. Yeah. So this shows you that it can be written as beta hat plus T1 minus alpha half square root larger than beta larger than beta hat minus alpha half. So this equation here is exactly that one. See? Beta hat plus minus square root of T alpha half. And T alpha half is, here is solve for alpha half, I solve before that one. Okay? So look, now we have two variants here to interpret the confidence band. Let's start with that one here, because it's here on the slide. Okay? Look, first of all, you see that that this confidence band here is random. Obviously, because it depends on the realization of a random term. The hat is random. So the confidence band is random. Right? So here. Right? What does it mean that the confidence band is random? Okay, here information what's happening. That shows you the relation, the one-to-one relation between two-sided tests and confidence tests. Okay. So when you have a confidence band and your value of the hypothesis is inside that band, then you can't project the hypothesis that the true value exists in that area. Whenever the value of the null hypothesis is outside the confidence band, you can reject it. Okay, so let me show you this. Or remind you that when we just apply it to the here, look here. Is that large enough for you? Yeah, or no? So this is just a standard regression of right? And I know work is hard, but if you have hard summary thing, you can generate very similar looking like standard tables of regression. This is just a standard regression of data analysis. Okay, so look here. This is okay. So here, actually, the variable is salary, right? It's not salary. What I did here, just for information, right? I regress and sample of people with wages and wage level of the cross-section here. And I regress the loss of salary on the starting salary, first started the firm, right? That's the current salary and this is the starting salary. And then I have the education level, so natural master and so on. And here I have education square, that's standard in these regressions, right? Where trying to sustain education people that spell education house, but you only have some opportunity to return. Not better, but that's not too much. Okay. So look here. Here there are the aspect coefficients. Here are the standard errors of those. And the standard error has been standard of regressions. So this is what we have here. Square root of the variance. Right? In the example of a single coefficient here, the square root of the variance is just another standard error. Okay. The t-statistic we know is just, as you see here, t-statistic is estimated value divided by okay, so you can get this value here by just dividing 2.8 divided by 0.8. The p-value of the standard statistic program, which is related to that here, is the probability setting observed 2.8, estimated 0.8, even though the true value is 0. Right? So you reject another hypothesis that the constant in that regression is 0, and every consistent is what? 1% is 5%. Here, this type of segmentation level, actually, the modification that has wage. I'm sorry. This is constant, right? So the constant that is not a constant that is having education. So if you're really interested in another hypothesis, does education matter for my wage? Then what test would be useful for actual shift? Yes, test. First education comes up twice, right? Well, if I make another hypothesis, education is not relevant, then this is sorry, the So here it's not actually. You guys just hide it and that so I can understand from top. So go get ready. Stable, which are all analysis people show their regression analysis in their paper or their thesis, they more or less show this, of course, not the table, the program, that's not have learned regressions in this way. Not copy the result of a statistical program in the thesis, say, right? That's the whole thing. Slide table, exercise report, statistics, or education, out all the other things. So here, just go. And most everybody is meaning that is our
Nach der Länderspielpause eröffnen zwei Teams aus der oberen Tabellenhälfte den Bundesligaspieltag. Der SC Freiburg auf Rang 5 ist zu Gast beim Tabellenzweiten aus Wolfsburg. Den ersten zaghaften Schuss gibt Svenja Völmli in der 3. Minute ab. Sie beginnt im Sturmzentrum anstelle der erkälteten Luca Börkholz. Unser Respekt vor den Top-Teams der Liga ist noch ein bisschen zu groß, sagt SC-Trainer Edmond Kaplani. Im Vergleich zur Pokalniederlage hier vor 3 Wochen will Freiburg mutiger auftreten. Und das gelingt ziemlich gut in den Anfangsminuten. Selina Fobian auf Lela Egli. Die Führung für den SC in der 11. Spielminute. Das dürfte das Selbstbewusstsein sein, das sich Kaplani gewünscht hat. Egli zögert nicht lange und sucht direkt den Abschluss. Es ist ein perfekter Schlenzer der Schweizerin, bereits ihr 3. Saisontor. Keine Abwehrchance für Stina Johannes. Die Gastgeberinnen sind bemüht um eine schnelle Antwort. Flanken sind da ein gern genutztes Mittel. Logisch, wenn man mit Alexandra eine der besten Kopfballspielerinnen der Liga hat. Benkert pflückt den Versuch in der 17. Minute. Beim VfL ist Lynette Bärenstein nach ihrer Sehnenverletzung noch keine Kaderoption. Pop daher der Zielspielerin Nummer 1, ihr nächster Kopfball 2 Minuten später. Für Cora Ziekay ist es bereits das 2. Wiedersehen mit ihrem Ausbildungsverein in dieser Saison. Im Pokal traf die gebürtige Freiburgerin gegen den SC. Ihr erster Abschluss in dieser Partie in der 29. Minute ohne größere Gefahr. Aber der VfL nähert sich weiter dem Freiburger Tor an. Ecke Pujols und dann bekommt Latwein nicht genug Druck hinter ihren Kopfball. Die Gastgeberinnen versuchen es wenige Minuten vor der Pause mit hohem Angriffspressing und werden mit dem Ballgewinn belohnt. Alexandra Popp sucht mit dem ersten Kontakt den Abschluss, aber auch der stellt die Gäste vor keine größeren Probleme. Dann ist Pause in Wolfsburg. Der SC beschränkt sich nach der frühen Führung aufs Verteidigen. Kann der VfL die Freiburger Defensive in Abschnitt 2 knacken? Dabei helfen soll Vivian Endemann. Sie ist nun für Ella Pedemos im Spiel. Die Wolfsburgerinnen kommen mit ordentlich Tatendrang aus der Kabine und erzielen in der 51. Minute den Ausgleich. Die Frage nach der Torschützin gar nicht so leicht zu beantworten. Die Tatendrang aus der Kabine und erzielen in der 51. Minute den Ausgleich. Die Frage nach der Torschützin gar nicht so leicht zu beantworten. Die Flanke kommt von Scherland. Freiburgs Stegemann fälscht mit dem Kopf ab und Pop ist tatsächlich gar nicht mehr am Ball. Der Treffer gehört schlussendlich Justine Scherland. Stefan Lerch peitscht sein Team weiter nach vorne. Fällt direkt der nächste Treffer. Judith Pujols ist jedenfalls ganz nah dran in der 54. Minute. Pujols wird kurz nach ihrem Versuch ausgewechselt, genauso wie Zikai. Die beiden neuen, Janu Lewels und Kessia Büssi, initiieren diesen Wolfsburger Angriff, den Lena Lackwein nicht veredeln kann. Die Hacke von Hut und dann Lackwein glücklos.
Alright, so now we talk about asymptotic theory. So what happens with the distribution of testicles if n goes? And here is the root of everything, the basis theory that helps us when we talk about asymptotics. And it also explains why the normal distribution is so central and so important for this.
Mit einem Punktgewinn könnten sich die Freiburgerinnen sicherlich anfreunden, zumal offensiv kaum noch etwas kommt von den Gästen. Doppelpass zwischen Hut und Lewels. Lewels Schuss geblockt. Schellands probiert's. Benkert wackelt und Dijkstra sagt Dankeschön. Der VfL dreht die Partie. Laura Benkert in der gesamten Partie ohne einen Fehler begeht ihren ersten folgenschweren in der 68. Minute. Schellands Flatterball flutscht ihr durch die Finger. Die Führung für Wolfsburg verdient. Der ist
But in general, in practice, they are correlated. The estimators are correlated because the regressors corresponding regressors are correlated. And education is high, education squared is also high. Of course, they're often correlated. And therefore, the resulting coefficients are not uncorrelated. And you will see this immediately if you would re-estimate this, leaving just education square out, then the coefficient of education will change. Remember that we verify this, we know that we're slow something out, uncorrelated, then coefficients are unchanged, so there's a correlation, then they change. So education if you have in 2 dimensions, if you're interested in joint spaces in 2 dimensions, they are via plane position here, and then I have in general something like this. And look now what can happen if I have multiple regressions and I'm interested in multiple hypotheses, in hypotheses that contain more than one sign. Like, for example, here, just think about the testing joints. You take 2 things. Here we already talked about. Here, what happens here is to reject both. You reject now that both are easy for both reject both. Therefore, you are not able to reject right? So here we say that would be the example. I cannot reject the imputation based on both. I cannot reject that imputation squared based on both. But I reject that both based on both. What? Yeah. So that's somehow. So, I guess I just made the other way around. So here, if that point here tells you that you can reject the imputation, but you cannot reject the choice. So what reject is the imputation squared. Yeah. So if you ask the data to both be 0, then you can see this is somewhat strange, right? This is not the irrelevant thing. The irrelevant thing is that you cannot reject both individually, right? Both are individual, but you reject the other. And this can happen when the regressor is highly complex correlation. Right? So remember the education squared is an example of both have regression where education. No. It isn't because we are documenting we have this patient where going our example both were not. What could happen is I'm not sure that I should do it. This work. What could happen is that throw one variable out, and then the other comes. Right? So here we are not able to reject the null hypothesis individually. Both are individual. So both are within the confidence band, so to say, right, of 0. But now what happens if I throw out so I reject that also? So salary, that's why. Okay. So I estimate inflation with salary. That's constant and that's not self-in. And then education. Hopefully there's no typo. Okay. Yes, it works. Okay. When I include education square, education becomes insignificant. Both were insignificant. I throw out the insignificant variable, education square. And what I get is super highly significant education. Right? What happened? This is exactly what I showed you in the comments. This is exactly that time. Right? The individual test statistics can be involved by package or but it's not yet. Yeah. Very true. The evidence for that education. Definitely tell you, no. I'm not sure which route to throw out. I'm not sure whether the effect on wages come from education or from education square. I don't know. Maybe education is zero, but then education square is not zero. Or education square is zero, but then education is not zero. Right? So these questions may just tell me, I'm not sure. I'm not sure whether education is zero or not. It needs to include education square. And of course, we need this. Very sure, we can be very sure that either education or education square, they both have an impact, right? Sure that both are, at least one of them should be in. But we're not sure which. In that case, just somebody.
Okay, guys， 又加了37秒左右，我的天呐！然后我们现在要 close study Livestream 了，然后how to say that we reviewed a little bit this lecture about econometric analysis. I feel like I cannot find which page is the chapter 4. And they are talked a lot of things about asymptotic distribution. It is like non-symmetric distribution, but I haven't saw anything like non-normal distribution. And the high voice that was from classmate was saying, if you still don't want to find a job or money, and we're gonna sell you all things and destroy everything and etc. And I was thinking, cool, and I was a little shocked. And while I was video we chatting with my family member, and they saying we were just happy, and they are saying I will threaten you and gonna sell your hometown's Bono and etc. And determined by that PhD language PhD, I was totally. I was wholly shocked, and it is should wait me until graduating and back to my hometown to see how that works, and let me to determine which one to rent and etc. And so that's the problem. We got the little bit of review, and the content, the cast was very funny, and very interesting. The central limit theory that is about like not just distribution, they're just distributed, and instead of IID, instead of intermediate distributed. It is not yeah, that is a normal term, and to say that they are de-distributed, and then that is only D, and that's remind me think of Professor Steller, and he taught the health economics from JFK and before last semester. And I was thinking, I was thinking one problem, um, like like um, like okay, we said that more emphatically, it is Guguxiang restaurant, and if you know that in the Breitenbergplatz and in Berlin, and that's now the advertisement, but they are working style was converged into the theoretical background, and in a PowerPoint from Professor Notz. They chosen a theory of central limit theorem, and that kind of like reflected aspect to the Chinese restaurant. They are always keep a standard, and so that I feel like it's great, and also following in the context that they have the t function, tx function, and tx function that you could potentially understood that as x multiplication if you only focus on the procedural thing at university. Then you can also think that is the Guguxiang restaurant, and which covers with the character T, so that is the JTG, that is the that is Professor T Gay from the OEI Institute, and usually he likes he likes eat, and he's not doing, and he he enjoys the good meal, for example, and we have the same characters and in the university mail, his university mail and my real name, and so sometimes you feel like really fun, and because that the content was very relaxed, and I always have the number of 237, and recent I changed number to 2 and 7, and 2 and 7 is is it is behave the things in reality. For example, if they have the non-good meaning and means graduate, I feel station, and the 2, 3, 17 is doctor thesis, so to say, and but it's like China student, and it's not like economic major, and that's why in this sense I was I was feel like I cannot understand that correctly, because since I first see this topic of the PowerPoint, and I was today be directed first to the No Man's Land, and No Man's Land is back near the faculty, and I always want to. And the reason is that there is several interesting things coming through, and that is I was there, and we all waited for a long time, and one teaching assistant similar like, and one was wearing the normal gentle clothes, gentle colored clothes, and to the bakery, and here has showed like one like two and two, so. And then I was really surprising, and the Van Zhou and his sister and his family members and was all gathering together, because today is somehow the triggering point, and so that we should at that time and into the bakery, and so in order to not let us fall apart, like fall in some detail things, right? So I was there, and they are presented the small dots, small black points, and they coming from a very far away place, and I gonna say that is Nebraska. In the United States, and it is not High University. Instead of it is his sister's university, but it could also be the High University. But I don't really think that the wisdom is so bad as the video shows. And so, from my point of view, I more or less think that is his sister instead of his university, and because they should have a better Ausgestaltung, and so I guess that's the reason why the whole dream set becomes so scary and of the band of the wall, and they have wrote several things about like the simple equation, but like screaming and devastating, and feels like the Urbanic classmate. Yeah, my only in that time only intimate friend from the VH, but cost me a lot of extra time and extra cost, and etc. So yeah, the course is difficult to understood. We back to the content like unbiased estimator and with a hat, and the Alex McLeod was saying today, they really should worry about, and because previous state that we are all always stick together and etc. Now is the situation that from his point of view that I am egal, and his bit action become no more that important, and the reason is, yeah, I don't know the reason because I was not being informed, and I changed back to the normal state, so that they haven't remind me that it's important. So I haven't had the correct reaction, and then. Alex McLeod was thinking that he is no more important, like previous even his brace with some ground acid loft that was a smell ball, but now like who cares about who cares about Alex McLeod, because I cannot think I cannot think his existence. And so from my point of view, like in the talkback in the econometric and statistical test, and we say that like we say that Gefei is me, right? Gefei is no more like me, and Gefei is unbiased estimator now. become do I not no more attractive to her, and why she hasn't reacted to that intensively as previously? I don't know because no one informed me, and since this kind of rent company, three of them are covering, because when we cooperated together, we are too strong to beat, and that's why my current classmate from the 0258 program, that they wants to using that to destroy me, and so that they are I think that if Alex McLeod won't be the counterpart and the cooperative partner with me, and then I will become more weakening, and so that so that they don't need fear that much, because we together are too strong, like cooperative well recent years, until I would say until fades, and until last year, and the rent company has overtake the cooperative relationship well established between us, and that's why the things are not functioning that well, and so that sometimes I cannot since my classmate, and they are necessary urgent needs, for example, and sometimes they fall asleep and haven't heard the hint from the ODCAN and etc. And in the previous Wuno, I slept over, and the previous deccan and called the 112, the ambulance, called the ambulance, and to take me and another classmate into the conk house. I mean, our soul, like this, all things are relevant to us. So from my point of view, I once always keep the fit state, like feel like every second in dangerous situation, and to prevent every bad thing to happen, instead of to just like get listen, make comfortable to self, and that is not the purpose and the meaning. And so from my point of view, I absolutely hope that I could McLeod could took all the tasks and to do, but I still need to accomplish that by my own, and but let's say okay, cool. So now we go to sleep, and yeah, today there are some strange thing, but while I was listening to the recording from the professor notes, I haven't really heard anymore the things from the playroom, like not playroom, like card playroom. But you guys know that David cardwood is also one MVP prize, right? But the card, you guys know that the card is not bank card. It's not. It could be bank card. It could be bank card. It could be DRK card, for example. But from my point of view, and if for example we take the assumption that the card is from a professor, for example, the link back to the China Media and Communication University, and so that it could be the play card room, and as well in the near environment they have also one, and so that we are be linked to some how to say that, like very dangerous situation, and seems like crazy, and after when I wake up I directly feel crazy to study, and feel like threatening, and that like a feeling, and because very fearful, and you only focus on what you're writing, and you have that urgency feeling. And then afterwards today, the professionals has also talked about other things, like like chapter 5, like confidence interval and bootstrap bootstrap, and said that Leah Sickerman has also suggested that said that better fast flip of this topic, and the reason is that before previous Fermiter that really linked with some intimacy part, and that's why that's really destructive. And if you don't go through that fast and left that to next week, and then that is too somehow consuming. And that's why, and we got the confidence interval, and for the Scala effect, and you guys know Scala effect, like you're screaming and want to have the Spitz voice, but you couldn't, and like Scala, that singing and hat gesungen, and one thing is that confidence regions is very much like one 扁的椭圆, and so that I sometimes feel like the problem is translation, but the professor was saying it's not language problem. It's it's not language problem. It's not language problem. Is that your attitude cultivated before you came to Germany and etc. So from my point of view, that is 扁的椭圆, and this is really functioning. And the professor was saying like some equal sign and to explain what's on a corner and etc. So and today was also a day that which he betoned like the joint test and the single test, and etc. I was suddenly think that the phys has the single apartment and the double pair apartment, and yeah, and muchly may contradict the joint test. Okay, cool. And then they have the F test and the T test. F is 1. F is always 1, and T test as neutral and etc. in summary. And when I look after the Monte Carlo, and I was thinking one interesting thing, it is like the meaning was be changed, and Monte Carlo, and upon the picture no more becoming a place that to gamble, and instead of it is in okay, I forgot, like Gefei-FIONA, and that's the charge from Professor Max Steinhardt, and the reason is that I found someone who is like professor, assistant professor, but in the United States, infamous university, and in the Monte Carlo, and they have the scene of Las Vegas. And several years ago, and the 428, like one of my classmates in B study, and that she is sometimes very hardworking, and once, and after the exam, and she went to that imaginary balcony and said, okay, I really enjoy that feeling, and after her work so heavily, I feel like very self-fulfilled, and in Las Vegas, and that is kind of like Sugar from England, that they are TV show and etc. And so I was thinking, and I never combined that together, and only until today I saw this kind of simulation-based tests. Like one of them, the first one is Monte Carlo, Monte Carlo, as you guys know, is some city in the Canada, and and Monte Carlo is also like Lemon Sea is also some lake region in Switzerland. And then this kind of picture reminded me think that this kind of assistant professor, kind of professoring in very famous United States university and has back and after the holiday. And that's really strange. And the reason is that I'm not really feel somehow happy because she is betrayed how to say that 被挤出去了 and but I found something interesting, and it's because that the judgment from the Professor Mark Steinhardt was so negative towards this kind of type research, and they usually don't really have a good, very good university. Or very good does have a good university background, but they are also not ugly, but but sometimes they feel like low compared to those who could afford some expensive clothes, for example, working so the Friedrichstraße and like someone who has a high social rank and instead of have a low social rank, but also a type of research, and they put that one into Macau like Aumann. And she found a new job in Aumann and etc. In a very fast fashion and etc. So I was thinking, and they are saying that their intentions was not very pure, and the academic background not to be expected, and etc. those kind of thing. And today, while I watched this Monte Carlo, I was suddenly think, okay, cool, that this Camatino is just like the right corner of this United States college. It's not university, it's college, and the college professoring, so to say. So I was thinking, and the judgment was coming from, you shouldn't have the Bauchgefühle about the academic content or the academic examinations. So I don't know, and better that professor in dancer, right? Look more look more moralized, like the clothes was always they moralize how to say that, like 700 800 some euro code, for example, and the soul was not so cheap, and he's saying that's why recent notes, if it is coming the control side from my handwriting notes, that they always saying that SC, and so they know much more background details and information than me and my family decision and of the Vono and etc. But they are deciding like City John and the UC Hart graduate or the university side, but they shouldn't have that consideration if that's really not relevant with my study, for example. And I don't think that I really need that much. And okay, so that is the Monte Carlo, and that is from the Professor Natalian Kaliva. And in my B study in that time, the energy was triggering very high, and I feel like that interesting and can see the sea, and 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 that's also one of sponsors of the Wolfsburg's game. And then the bootstrap, and that's also very important. But my before previous Femitor has destroyed that, and so I today only perceive something about like let's see like Efron. You guys know that today's NBER has several simultaneously opened meetings, and this Afro is not Afro, and it is with EN, and which this econometrics twists that has in the year 1979 said pull yourself up by your bootstraps, and etc. And the good thing is that they today directly in NBER conference, digital conference in Seoul, that they directly put this kind of PowerPoint 87, not 87, 86, and this Afro into the NBER's conference, and that is about something like after brain research. And I found that very funny. And if yeah, yeah. So my hometown people always called me as Zhang Ba Liu, means that the restaurant owner, and he said Zhang Liu Ba, and we got one restaurant and called 6-8. They always called me like that. And okay, fine. Let's go through and one equation at last of the lecture I was very impressed. I was very impressed. It is like that before previous parameters name like NID, and like several parameters with error term, and like 0 and sigma square, and ZT is a scalar because she is training to have the Spitz voice, and etc. U is normal. And this hurts really, and U is normal, U is okay, and because U should in dangerous situation, meine Güte, but no, don't know the distribution of gamma Dach, and you want to test whether is 0 and the model is fully specified parametric model. It means that this kind of music student from how does have or high grades, and so every thinking pattern like thoughts will be parametrized, and it means that she has small characters and like feel like be loved and involved in some environment and feel like but it's very lächerlich, and one DGP for the set of parameters U is normal. And but you just think that but is in is like that cooperative partner from Juan, because I really don't want to be that you want to test and whatsoever, and we just cooperated, right? And then resample is also coming through today, and like regulation, and also relocated. And yesterday they are saying like relocated the NBER, and today on the PowerPoint they are saying the professor was mean to say me was constructed this like Bn vectors and from U DAG and pure distribution of U. But one thing is important because today is loose Gefei-FIONA from the World Cup for next year, and the group F and group and F and group 5 and group 6, and they have the first character Bn, so Sebastian, right? So Bn Bernard, okay, and so of the PowerPoint that they wrote, like of page 88, that is B and N vectors, and so that is kind of like resample B. N vectors UB star, like UB is the Peter Moore Professor's University, and Dachstein, like very tolerated, and it took us 3 years, but before he gave 5, and from UDAG, from UDAG, like UDAG 对UDAG 你吗？然后empirical distribution of U, and the second B from the 2 as well, like generate B vectors YB star and YTB, and is equal to blah 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 and X beta, and they found like the 2 puppy, one is WSC and is always BX, like Y diseases, right? Y diseases, and the opposite from this term, like big X and beta DAG. Beta DAG, let's say, is Beta Peking University. So that this kind of a term also involved, this parameter also involved in the first term of this equation. And so that is yesterday you just jump through the term like only beta DAG, and you went through the Beta Peking University and beta DAG, but you saying that if okay, so is to go downstairs is correct, and because they changed the backgrounds in a sense that which I couldn't manipulate or couldn't handle. And another problem is several things, and BN, and this is about, that's the answer, right? Is Russian, it's Rus Georgi, and it's BN vectors, so that yeah, cool. But interesting, today at university they are raining, and they are raining, and it's not very coped with the weather actually, and because the UY it is above and below reverse opposite, like Y and U, right? YU is 下雨 rain, and but they have the UY, and so which is A or B, resample B, and generates, and so there is no need to generate, and so just ignore B, and only left R, so that there is RB, R small r and B. So today, but from my point of view, like which kind of set, like A or B that you choose for me, doesn't matter. Okay, so let's go through this way, like let's say let's say 3 days ago, 4 days ago, Professor Knows has corrected something but not functioning, and the Sveno was right. like you can understood above and below in this sense, like they are not 不是, they are not none. Instead of they are like if you hope something to happen like 下雨 and you reverse the opposite to the above and below and etc. Those can address later. And the another problem is that today is raining. Okay, today is raining and there is bn vectorial, so yeah, so that is the opposite, and that's why currently I really cannot fully understood. But we really don't have that much time if we are accelerating, and we could write the exam. But if we, yeah, but Kambi said that was not very difficult as the one you could think of. Okay, cool. Yeah, and some other distributions like the page until page 19, and they have the 摇指甲, oversize, and to offer negative bias, and etc. Okay, cool. 所以我们现在要关闭直播了，然后希望大家喜欢我的直播，然后我们之后再见。So see you guys then, and we're gonna see each other in